Find the third derivative g triple prime of x for the function g of x equals x squared over x squared plus 1. So g of x here is the quotient of two functions. We have x squared over x squared plus 1. The first derivative will therefore make use of the quotient rule. The derivative of the numerator, 2x, times the denominator left alone, x squared plus 1, minus the numerator left alone, x squared, times the derivative of the denominator. Derivative of x squared is 2x, the derivative of the 1 is a 0, and then the entire thing over the denominator squared, x squared plus 1 squared. In the numerator, I'm going to distribute this 2x in here, giving us 2x cubed plus 2x, and then I'm going to multiply the negative x squared into 2x negative 2x cubed all over the denominator, x squared plus 1 squared. The 2x cubes can combine and cancel, one positive and one negative, leaving us with 2x over x squared plus 1 squared. There's the simplified version of the first derivative. We still have a quotient, so the second derivative will also involve the quotient rule. We'll have the derivative of the numerator, which will be a 2, times the denominator left alone, x squared plus 1 squared, minus the numerator left alone, 2x, times the derivative of the denominator. Now that's a power rule. We'll bring the power down, leave the inside alone, subtract 1 from the power, it'll be to the power of 1 now, and then multiply by the derivative of the inside to complete the chain rule. And then all of this will be over the denominator squared. In the numerator, I'll leave the first term alone. We do not want to FOIL out that x squared plus 1 squared because I will have a common factor of an x squared plus 1 in the numerator. The second term, I have a negative 2, a 2, and a 2. Everything's multiplying each other, so negative 2 times 2 is a negative 4, times 1 more 2 is a negative 8. I have an x and another x. X times x will be x squared. And then I have that x squared plus 1 that we will be able to factor. In the denominator, I have x squared plus 1 squared, and then squared again, raised to an exponent to another exponent. You multiply the exponents, 2 times 2 will be a 4. In the numerator, I have a common factor of an x squared plus 1. I also have a common factor of a 2, but I'm not going to factor that out since there's nothing in the denominator to cancel with. We need to take one more derivative here. We need to go to g triple prime, the third derivative. So I just want to simplify this enough to make the derivative easier. We don't want to factor numbers out if they don't cancel. But there is a common factor of an x squared plus 1 to the first power in the two terms. If I factor out from the first term, I will take away one of the two. I'll be left with 1 power of x squared plus 1. And in the second term, I'm going to take away the only x squared plus 1. And by doing that, I can now cancel that with one of them in the denominator after you factor it out. All of this is to simplify the look of the second derivative to make the third derivative easier. Now in the numerator, we can distribute this 2 in here. So we will have a 2x squared plus 2 minus x squared over x squared plus 1 cubed. And we can combine like terms in the numerator. Now I have a 2 that I'll write first since it's the positive term. I have a 2x squared minus a 8x squared, which will give us a negative 6x squared. And I'll write that second. It's customary to put the positive terms first, the negative terms later. Over that denominator cubed. One thing to notice with the denominator is we take successive derivatives. The original function had x squared plus 1 to the first power. The first derivative had x squared plus 1 to the second power. The second derivative has x squared plus 1 to the third power because we factored an x squared plus 1 and canceled it. Notice that its power continues to raise by 1 each time in the denominator, and that's a pattern to be aware of there to make sure you do the correct cancellation. The third derivative, I expect to find the denominator to be x squared plus 1 to the fourth power. Our third derivative will once again be a quotient rule, since we have a quotient of functions in our second derivative. So we will have the derivative of the numerator. The 2 will be a 0, and the negative 6x squared will be a negative 12x, times the denominator left alone, so x squared plus 1 cubed, minus the numerator left alone, the entire quantity, times the derivative of the denominator, which is going to be a power rule. We'll bring down the power 3. We'll leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. All of this is over the denominator squared. Now in the numerator, I have a negative 12x and an x squared plus 1 cubed. I also have a negative, a 3, and a 2. Putting those together, I have a negative 6. I have an x. I have the 2 minus 6x squared, and then I have the x squared plus 1 squared. All of this divided by x squared plus 1 to the 3, and then to the 2. We multiply those exponents. 3 times 2 is 6. The next thing we're going to want to do here is factor the numerator as much as we can to simplify. And I can start with factoring out a constant negative 6. There's a negative 12 here and there's a negative 6 here, so a negative 6 and an x with that, so negative 6x. And that will leave me with a positive 2, and then the x squared plus 1 cubed, and a positive 1 times the 2 minus 6x squared, and then an x squared plus 1 squared, all over the x squared plus 1 to the 6th power. We also have a common factor of powers of x squared plus 1 in each term. In the first term I have a power of 3. In the second term I have a power of 2. I can factor out the lower of the two powers. So that will be the power of 2. If I factor out a power of 2, I will take away 2 of the 3 in the first term, and I will take away both of them from the second term, leaving us with just the 2 minus 6x squared. Over that denominator. Now that we've factored that out, I can cancel those 2 with 2 of them in the denominator, which brings our denominator to the 4th power as expected. Now in the numerator, I have the negative 6x, and in the square brackets I'm going to distribute this 2 in here. 2x squared plus 2. I'm going to remove the parentheses here by distributing the positive 1 into there, so I have a plus 2 and minus 6x squared all over that denominator, x squared plus 1 to the 4th. can now combine like terms in the numerator and the parentheses. So g triple prime of x will be a negative 6x times, combining like terms, I will do the constants first since they are the positive. I will have a 2 plus 2, which is a 4. And I have a 2x squared minus a 6x squared, which is a negative 4x squared. All of this divided by x squared plus 1 to the 4th. So there's now a common factor of a 4 in the parentheses in the numerator. I'm actually going to take out a negative 4. And the reason for taking out the negative 4 is that will allow the sign in front of the negative 6x to become a positive. So I'm going to factor out a negative 4. I'll just do this in steps here, but that's going to cause the 4 to become a negative 1 and the negative 4x squared to become a positive. So it'll be an x squared and then a minus 1. It will change the sign on each of those terms and take a 4 out of them. Now the reason for doing that is the negative 6x times the negative 4 can become a positive 24x. And it's always best to have fewer negative signs whenever possible, and that would make it have fewer negative signs. And there is the simplified version of our third derivative, g triple prime of x. 24x times x squared minus 1 over x squared plus 1 to the 4th power.